Hello, all of my not friends. Happy Halloween. I guess it's happy post Halloween. This is gonna be a video for your notes for today, and I'm just gonna fill in kind of this part of the slide. But I want you to make sure that you're also including this in your notes. So anything that I write down in this video, minus the part at the end, make sure that you get it included in your notebook as well. So at any time, if you feel like you need to stop it, pause it, rewind it, just make sure that you get all these notes in because it's really important for this lesson and kind of the continuation of this unit. So the first thing that we're going to be doing today, this is all about function notation, and it looks kind of fancy, but in reality, it's not that fancy. We're going to be introducing f with parentheses around it, this kind of notation here. It's just another word for y equals 3x plus 4, but now we're going to call it's called f of x, or function of x. And the reason that we use this notation is kind of for a couple of reasons. First, to indicate that it's a function. So we're saying this, in fact, is a function. It's not just, a bunch of squiggles on a line or a graph or some scatter points. We're indicating that this is a function, this particular graph. The next reason that you can think of it is that this is actually something that mathematicians do, people do. We name things. We like to name our car, we like to name our shoes even, we like to name our children, we like to name a lot of stuff. So mathematicians also do things. They name their equations. So instead of it saying y equals, now this is the function f, and you can even think of it being like, this is function Frank, this is his function, and that way it can kind of say, if we have multiple functions, that way we're not just saying, hey, you over there, come over and talk to me. We can say these are different functions, they have different names. So when we're looking at a couple of lines at the same time or a couple of different equations, we now have a name for them. So the name for this one is f. So that's kind of the first part of this box that we're going to fill in. This is the name of the function. So these are kind of our different parts. This function is named f. And the way that we read this, we can call it function f. That's one way to read it. It's not f times x. It's a notation that also can read f of x. The part in the parentheses, again, it's not multiplication. It's actually indicating what our independent variable is. It tells us what number to plug in or substitute. We'll just say plug in. We don't have to do substitute. It tells us what number we're plugging in. So today we're going to be using this, and we're going to have numbers in those parentheses, and that's just saying, hey, can you make x blank number? And like I said, it takes some used to, but I'll do a lot of examples in this video to make sure that you're comfortable, and then you'll practice it again afterwards. And this whole segment here, this whole thing, is just kind of another word for y, or whatever our output is. So as a whole, if it's got the f, if it's got the parentheses, if it's got the x. Or sometimes we don't name it f. Sometimes we name it g for like maybe Geraldine or George. So whatever our function is, f, g, it kind of goes, and there's a lot of different orders, but whatever it is, that whole thing, when it's united with no number in it, that's indicating that that is our output, or our y. And then this is the actual function, 3x plus 4. So the kind of pictures that we're going to do for this is we're going to be kind of thinking of this. We're going to use the same function, 3x plus 4, as machines. So this is a very interesting notation. You're wanting to think it's f times 2, but it's not. It's, again, it's giving you what our x is. It's telling us what to plug in. So in this case, we are going to take our function f, and we are going to send this 2 through the function. So you can kind of think of it like a little machine. You send the 2 into the function, which is our function f, so 3x plus 4, and out's going to pop an output. So if I plug in 2 into 3x plus 4, I get 3 times 2 plus 4. So we're really just substituting. 3 times 2 is 10. I'm sorry, is 6, and then plus 4 is 10. So that would be our output, would be 10. In the notation on that, we're really just plugging in numbers, right? So when x is 2, we plug it in, we get a y value of 10. So our notation that we do is f of 2 is equal to 10. And even when you make it kind of on the table, if you're thinking of it that way, your x would be 2, your y would be 10, right? Same thing. These are all the same kind of, it's just different ways to look at it, but we're talking about the same thing. You can also even think of it as an order pair, 2, 10, right? All of those are meaning the same thing. So we can take this negative one, right? We're going to throw it through the same machine, and we know that because it's telling us to use machine F, which would be Frank. So we're going to put it in Frank, which is 3x plus 4. We're going to substitute the negative 1 in. So we're going to do 3 times negative 1, which is negative 3, plus 4, which is 1. So we're really looking at, again, we're looking kind of at that xy table. Negative 1, output is 1. Or we're also looking at it as f, and that reads f of negative 1. Or when x is negative 1, the output, and even thinking of output as after. It popped out a 1. It equals 1. The after is 1. So that's what that one would be. And the same thing, or negative 1, 1. So this is helpful when you have many friends, right? You know, it's easy when you go to the playground and you're the only kid. You could say, hey, you, kid, over there. But if there's a lot of kids, you want to make sure that you have a name, so that way you know who to address when. It's the same thing in this case. Now we have 2 functions, so we have their names. Here's Frank and his alter ego, x squared plus 3. And then we also have George, right? There's George, the function g, and that would be x plus 1. So now, when we're talking in each problem, we know who we're talking to. In this one, we're talking to Frank, because it's saying f. So for Frank, we're going to use his function, x squared plus 3. And we're going to take out that x, and we're going to plug in what's in the parentheses, which is a 3. So all we're doing is substituting. So that'd be 3 squared, 9, plus 3, which is 12. For this one, they're not talking about Frank. They're talking about George. So we need to use George's function. So instead of saying x plus 1, we're going to use what's in the parentheses, which in this case is a 3. So we're going to say 3 plus 1, which is 4. And now we're going to go back to Frank. And we're going to say, Frank, now I need to substitute in a negative 2 for the x. So instead of it being x squared plus 3, I'm going to do negative 2 squared plus 3, which is 4 plus 3, which is 7. And then I'm going back to George. And I'm saying, George, I'm going to plug in a 0 for you. So 0 for the x plus 1, which is 1. So it's really just kind of almost like fancy substitution. But it is helpful in this case because when you have 2 different functions, now I know, well, who am I substituting into what equation, what expression, which function? Where is all these numbers going? So it's kind of a more clear way. Like I said, it's like calling out kids. You don't want to say, hey, you over there, that kid. It's easier if you know a name and you can identify with the name. First and last name, even more specific, right? In case there's more than one kid at the park with that name. Okay, so looking at this, this is the same kind of thing. So this would be like a kind of a state question. If we have f of x is equal to negative 3x plus 1, and they're saying what's f of 3? So we're going to plug in 3 for the x value there. So we're going to say f of 3, oops, I put negative 3, f of 3 equals negative 3 times 3 plus 1, which is negative 9 plus 1, which is negative 8. So there's your answer. The way you would write this as an ordered pair, well, my x, remember ordered pair goes x, y. My x is 3. My output was negative 8. The way you would write it as a function ordered pair would be, you would say 3, and then your y value is the output, which is f of 3. And you could even write it really in the way of the function, which is f of, oops, I used g, this is not George. Let me see. F of 3 equals negative 8. That would actually be even better. You'll see that a lot of times. And that just means that your x value is 3, your y value is negative 8. Now this part you're not going to write on your notebook because I didn't print out graph paper. So just kind of follow along. They're very fast because there's no arithmetic involved. So for each one of these, I'm still giving you the x value. And usually in the instructions, they would say something like, on the graph below is represents the function f of x. So we know that this is going to be function f. So they would give you some type of clarification on that part, that this line is f of x. So then you would know, well, if I'm looking here, and they're telling you when your x is 0, which would be here, right? What is the y value? So you kind of, on the x-axis, kind of roll up or down, depending on if the line's above or below, and you hit right on the line where that x value is. So this order pair here is 0, 2. So they're saying if x is 0, then that must mean my y is 2. So that's what that looks like. Well, what about when f is 4? 1, 2, 3, 4. If I roll up, I hit 1, 2, 3, 4, 5. So this order pair is 4, 5. So when x is 4, my y value is 5. Negative 4. 1, 2, 3, 4. Right there. So this point would be negative 4, negative 1. When my x value is negative 4, my y value is negative 1. So again, anything in the parentheses is always going to be kind of your independent variable. In this case, it's x. Negative 6 would be 4, 5, 6. You know, that looks like it's about negative 2.5. So that's how you would do it on the graph. Again, it is kind of strange, right? But just know it's a format thing. It helps us indicate where we're putting numbers, which types of equations that we're substituting them into, and also be aware of that different number. Make sure you get these things copied in, and then you're going to go see the sub. He should have a class worksheet for you to work on that just does the same kind of thing as here. It has a couple functions. Usually our functions start with F, like Frank, then G, like George, and then H, like Harry, or Hazel, I guess, right? Like my kid, etc. So usually they kind of roll on from there, and you'll complete that, and then you can turn it in and then start your homework that's on MathSpace. Thank you so much, and have a great weekend. I'll see you guys next week.